This video is a brief introduction to Chapter 6, Systems of Nonlinear Equations. So the outline for Chapter 6 is a brief introduction covered by this video, and then the fixed point iteration method and Newton-Raphson method. So in Chapter 5, we considered systems of equations that can be expressed in the form ax equals b, where a and b are constants. A is a matrix and b is a vector. The fact that they are constants makes these problems linear. Instead, if a and b are functions of x, then we have a nonlinear system. So for example, we can have a of x times x is equal to b of x. So for example, consider the system of equations shown here. These can be written in matrix form as shown here, and you can see that our matrix A is no longer constant, but actually contains our variables x1 and x2, which makes this a nonlinear system. Some transcendental equations cannot be expressed as a matrix times a vector in the same way that we're showing here. So for example, the system of equations described here, x1 minus 3 sine x2 equals 4, and the natural logarithm of x1 plus e to the power of x2 equals 8, we can't just write that in as a matrix of coefficients times our vector of unknowns as we have in the previous cases. And this again would be considered a nonlinear system. So a nonlinear system of equations occurs when we cannot represent the system as a matrix of constants multiplied by the vector of unknowns. So here we limit our discussion to nonlinear systems composed of n equations and n unknowns. There are some analytical methods to solve these types of equations. However, in general, a numerical method is the fastest way to find a solution. And nonlinear systems require iterative methods to solve. So we will consider two such methods in this chapter, the fixed point iteration method and the Newton-Raphson method. And we'll see in the next video how these methods come about as extensions of the methods that we have talked about in both chapters 4 and 5.